the Indian number of two-wheelers is around 20 crores. So India has around anywhere between 18 crores to 20 crores two-wheelers running on the road. The total EV penetration is only 20 to 25 lakhs. We were the first ones in India to come out with a microprocessor-based BMS. Startups that have grown, like Ather started as a battery company that went into two-wheelers. Ola, the scale they wanted probably requires to control the entire supply chain, which is very erratic today. And that is why we saw a lot of fire incidents happening in 2021 and early part of 2022.
Hello and welcome to the Evo India podcast, and today we're going to be talking about electric vehicles, but we're not going to be talking about the finished product. We're going to be talking about a very critical component that makes electric vehicles what they are, the battery pack. And to give us insight that we wouldn't normally have, we have with us Pratik, who's the co-founder of Neuron Energy. Hello Pratik and welcome to the podcast.
Hi, and nice having me over. Thank you.
Thank you. So let's get straight into it. Tell us about Neuron Energy and how did you all get around to doing what you all do?
Well, we in 2015 were looking at multiple businesses. So I did my master's in finance from US and I got back in 2011. After coming back here, I was briefly working at JLL, which is a real estate consulting company. After that, I joined my family business for a couple of years from 2012 to 2014-15, which is primarily into real estate development. At that time, we were also looking, apart from real estate development, to develop alternative new age businesses. We were looking at LED, solar, clean tech. By that, 10 years ago, electric mobility was not that relevant. We happened to come across batteries and how batteries would play a larger role in the future. And that is how we got into the segment in 2018. We started Neuron Energy in 2018 with the idea of supplying electric two-wheelers, three-wheelers and electric golf cart batteries. And we started off with a lead-acid platform to be given out. At that time, lithium-ion batteries were not that prevalent. And as things moved ahead in 2020, we built a very strong R&D team and we developed lithium-ion batteries which were introduced then in India. And that is how entire journey has been. We never planned that we would be doing the entire gambit of electric vehicle batteries that we are doing now when we started off. And as the market moved from lead acid to lithium, from one technology to the other, we kept developing that as we went ahead.
Right. Okay, so that was the starting goal. So you all started off with that. Now, what have you all forayed into right now?
So currently we are doing everything that's electric. So we are doing electric two-wheelers, three-wheelers, LCVs, electric four-wheelers. We have made prototypes for electric four-wheelers. Buses and trucks, we have batteries with liquid cooling, without liquid cooling solutions. Over and above that, we have made a prototype for an electric marine boat, which we are talking to the government for Navy. Over and above that, niche areas like drones, electric drones, floor cleaning machines, aerial work platforms, golf carts, etc.
Right.
So right now, anything and everything that moves on electric, whether it is a vehicle or it is an unmanned vehicle or a robotic application, we are currently supplying batteries for all of that.
Right. And what is the most popular product in your portfolio right now?
The most popular is for electric two-wheelers and three-wheelers. So we are 80 to 90% of the revenue is generated through batteries for electric two-wheelers and electric three-wheeler applications. Okay.
So we are like Evo India with cars and bikes. So we're more interested on that side of things. Correct. So tell us more about your two-wheeler and four-wheeler customers and what do you all do for them in terms of product solutions?
So currently in two-wheelers, so again, we start off at a time when they are designing the two-wheeler. So the entire powertrain, when it is designed, the motor, the controller, and the cluster, that is when we enter in. And based on meetings with the R&D team of the OEM, that what kind of range are they targeting and what kind of average or the range that they require based on their marketing inputs, we design the battery pack. So it's an top-down reverse approach wherein all the other components are fitted in and based on that the battery pack is designed. So we integrate the entire battery pack and the powertrain together to ensure that there is no issues when it comes to the software or the hardware. And the current flow, the technicalities are in place. If we just supply a battery pack as per their requirement, then it would be very difficult to integrate the pack. So we have worked with multiple OEMs today. We are supplying to many two-wheeler OEMs, around 6 to 7 today in the country. Over and above that, we are also supplying to battery swapping companies in India, which have a large swapping portfolio where they are using two-wheeler batteries. They are swapping it with two-wheelers and three-wheelers both. And the swapping portfolio is mainly towards the fleet, addressed towards the fleet, where they require the batteries to be swapped and they need to do the deliveries on the go. And apart from that, when it comes to the OEMs, we have two models. One is where we design the battery, manufacture and give it to them. Second is we have an implant model wherein we set up our own factory within their premises and we manufacture the battery in their premises. This is a just-in-time approach wherein we save a lot of logistics time and also we ensure that the client has complete control over the supply chain of the vendor.
So the second module you're talking about, is it where the battery is of their design and y'all are manufacturing it for them, or in this case also you have designed the battery for them?
All batteries are designed by us.
Okay.
We manufacture, this would be a dedicated plant per se. The other plant would give out to everyone.
Right.
And this plant is based out of the two-wheeler manufacturer's plant itself.
Okay.
So we are making the batteries inside their premises.
Right.
So we have done that with Komaki right now, where with the brand we are manufacturing around 3,000 odd batteries within their factory itself.
And this 3,000 is like per month, per
Per
year?
month.
Per month.
Per month. 3,000 per month within their premises. So this allows the two-wheeler manufacturer to have just-in-time inventory for their dispatches.
Right.
Second is it saves on the logistics time.
Makes sense, yeah.
And third is that they also have complete faith and trust in terms of, and transparency in terms of what materials we are using and is the battery pack that is going to them as per what norms we had agreed or the standards we had agreed between them.
Correct, because it's happening in their own facility.
So to build that trust, transparency, we have come out with this model where we are doing significant amount of capital expansion. But we require scale. We cannot do it at a level where we set up a factory at 500 packs a month or 1,000. We need minimum 2,000 to 3,000 packs a month to set up this model.
Okay. Can you name some of the OEMs that you're associated with right now?
We are supplying to Komaki as a large OEM. Cosmic is the second OEM that we are supplying to. They are based out of Kolkata. We are in talks with other companies like Bigos for supply of battery packs. Jitendra EV traditionally we have been supplying to. Electrics traditionally we have been supplying to. So there are many players in the top 10 that we are supplying to. You will see Ola, Ather and all making their own batteries. So beyond that, there are many 7-8 people in the top 10 area where we are in touch or we are supplying battery packs to.
Okay. And what is one of the major challenges when you're designing a two-wheeler battery? I'm pretty sure packaging constraints would be one of them, but from a manufacturing and a designing point of view, what are the major challenges that you face there?
So design is per se not a big challenge today. We have the right market fit. We have tested our packs. We have been in the market for 7 years. So we have seen 2 warranty cycles. The issue in India today is pricing. We have the top quality of cells, access to the top quality of cells. We have deep partnerships with our vendors, be it the likes of LG, Samsung, Goshen, REPT, Eve. These are the top cell manufacturers today globally. And BYD, we have partnerships with them already in place. Today, the challenge that we face is that electric two-wheeler market is extremely price sensitive. So we see many startups trying to grab market share with very aggressive two-wheeler pricing. Over and above that, they have to compete with other OEMs, so other ICE vehicles. So EVs are not only competing with other EVs for pricing, they're also competing with ICE.
Right.
And ICE is obviously cheaper than EVs. So the only benefit that the customer gets with ICE is the operational maintenance. But the upfront cost many buyers today are not willing to spend. So to increase adoption and to ensure that the numbers and the volumes of EVs go up, we are seeing more and more pressure on pricing. Because of that, there is a reverse pressure on all vendors to support the OEMs with pricing. And battery being 40% of the cost of the vehicle, we see tremendous amount of pressure coming on us to ensure that we deliver the battery at a certain price to the OEM. So that erodes our margin. And if we go back and reduce the quality of the cell that we are using to ensure that our profitability remains intact, it will lead to a lot of quality issues,
Correct.
which we don't intend to go in.
Correct.
So the challenge mainly comes from the fact that today it's a nascent industry. You need deep pockets to survive this era. The cell pricing has reduced significantly right now. Last year we were selling somewhere around 17,000 rupees per kilowatt hour. Now we are selling somewhere around 10,000 rupees per kilowatt hour. So the cost of energy is reduced by 40-45%.
But is this going to be a consistent and a steady decline, or is this volatile, this market?
We expect this to be steady. We don't see the decline going below 8,000.
Okay.
If we take energy coming out of lead acid technology today, which has been a stable technology for the last 140 years, the cost of lead acid technology is somewhere around 5 to 6,000
Per kilowatt.
per kilowatt hour. So if you have a delta over it, lead acid life is also shorter. It's a 1 year life on the battery for electric rickshaws and electric two-wheelers. So
And are they less energy dense as well compared to?
Very less energy dense. So it's very voluminous and very heavy. So if lithium-ion has a life of 3 to 5 years, so if you consider that as the delta over, it can't ever match lead acid today.
Correct.
But if you put a delta over it, I think 8,000 would be the place at which it should be fine. So we are almost there. We were at 17 last year. So adoption is natural that it's going up because of the reduction in battery price, which obviously we pass it on to the OEMs pass it on to the consumers. So the price of the vehicle per se has dropped because of this reduction. However, having said that, there is still a fight to gain market share. So new startups are not only competing with themselves, they are also competing with incumbents. So like the larger ICE players who have sales distribution more so ready because they have been in the business for the last 30-40 years. So keeping that in mind, the pressure is more towards delivering a very high quality product at a good price. That is more of a challenge rather than designing the product.
So do you think these players who are giving exorbitant discounts or pricing their EVs very less are running the risk of loss, because what if the product doesn't take? Then how do they make up?
So if there is sales that is happening, there are people who in India will buy at a price point. We don't see low unless the product is flawed or not well made. We don't see the product not selling if the price is lowered. So sales will come in as soon as price is dropped. It then depends on the company strategy and corporate strategy of that particular group, how they want to gain market share and how they intend to balance out the volumes. So it is an individual call that how they position themselves. It is also about having that kind of capital available to ensure that they can do it for 2 years, 3 years, and then over time, when things cool down, EV stabilizes a bit, they can probably have a better pricing strategy or they can compete with others, etc.
Right. And what capacities batteries do you all make for two-wheelers? Like what is the smallest to the largest? What's the range?
We do everything. We have more than 200 packs that have been designed for different models. Komaki itself, we are supplying 12 to 14 models to them. So we are doing anywhere from 1 kilowatt hour to 3 to 4 kilowatt hours in the two-wheeler segment.
Okay. And do you have any liquid cooled options for the two-wheeler segment as well?
We do have, but we don't have demand for the liquid cool options.
Okay.
And we don't recommend that either. We believe that liquid cooling is good, but at 2 kilowatt hour to 3 kilowatt hour, we don't really require liquid cooling. If we go for a better chemistry, which is a safer chemistry, or if we design the motorcycle in such a way where the pack can be air cooled and liquid cooled, it would be much better. So we have liquid cooling packs. It will add to the cost.
So liquid cooling in a battery in this application, are you looking at longer life or better thermal management only, or the byproduct of that can be more range and performance as well? Rather, where is the balance going towards? More performance or more range?
No, liquid cooling is only thermal management.
Only thermal
Absolutely,
management.
only thermal management. It will not add to any range. It will add to life, because if the pack is liquid cooled, it will be maintained better.
Right.
So it will not have those spikes in thermal management, which affects the life. But that will be a smaller delta. It can't be that normally the life is 1x and it will become 2 with liquid cooling. That won't happen. But each cell has a life cycle data sheet. So if you liquid cool the packs, then it will be truer to the theory on paper that if the pack is designed for 1500 cycles or 2000, it will live that life.
Okay.
However, liquid cooling is not compulsory for everything. It depends on the design of the scooter, bike, whether you should put in, not put in, etc.
Right.
Secondly, we are a tropical country. So there are two chemistries, LFP and NMC. So NMC is more prone to fires because of the energy density and the materials used in the chemistry like cobalt and manganese. LFP is less prone to fire, and NMC works better between minus 25 to plus 25 degrees Celsius. LFP works better between plus 10 to plus 60 degrees Celsius. So we see NMC running better in Europe and China, more penetration of that chemistry because of the temperatures there. But see, considering our temperatures on ground, it won't really be below 40 either. So if you see a vehicle running on the road, it will be 42, 43, 44 on the road with continuous sun beating down. So you need LFP as a chemistry which is better. However, NMC is proven to be a better chemistry application for two-wheelers. Although three-wheelers, four-wheelers have moved to LFP completely. So we are seeing a mix of the two today in the market. LFP is voluminous and with lesser energy density, it might not fit into the two-wheeler completely or into the design. So it depends from player to player on what strategy they want to adopt into.
Okay. So now you have companies like Tata entering the battery space. You have Exide also entering the battery space for EVs. And Ola already has been around for a while. So how do you go against these the competition like this?
So Tata again has a company, Tata Autocomp, which is making the batteries so Tata Autocomp is a JV between Tata Group and Goshen, where they are making the batteries for their Tata Motors, Tata Curve and Nexon, so on and so forth. So they have also set up a company to make these batteries and sell to the OEMs. Today the volume is way too low of EVs. Electric two-wheelers to an extent has started picking up. So if we talk about two-wheelers, we have around 20 lakh to 25 lakh odd two-wheelers in India today.
Okay.
The Indian number of two-wheelers is around 20 crores. So India has around anywhere between 18 crores to 20 crores two-wheelers running on the road, with the churn of around 1.5 crore to 2 crore two-wheelers being sold every year as new two-wheelers. So we see that every 8 years, the entire population is going through of two-wheelers is going through a change.
Right.
Now the thing is that out of 20 crores, today the total EV penetration is only 20 to 25 lakhs. All put together.
Okay.
So it's around 1% only. However, newer sales that are happening, you see that the EV percentage of the total new scooters that are sold is much higher.
Right.
So we see that today around 1 lakh a month or 1.5 lakh scooters a month are being sold. So we see this number of 20 lakh increasing significantly over the next...
You're saying 1 lakh EVs are being sold a month?
Yes, easily. So if you see Ola's numbers are itself in the range of 30,000 odd. They are being selling. And if you put low speed, high speed all together, 1 lakh to 1.5 lakh is what is being sold per month. And we expect these numbers to grow over the next 10 years significantly as newer players come in, markets develop and so on and so forth. With four-wheelers, the numbers are way lower. The penetration is also lower. So as volume picks up, we will expect the OEMs to have partners, because today they are controlling the entire supply chain, which is necessary. The startups that have grown, like Ather started as a battery company that went into making the two-wheelers. So they had battery came naturally to them before the two-wheeler came.
Right.
Ola, the scale they wanted probably requires to control the entire supply chain, which is very erratic today, considering we don't have cell manufacturers in India. So from cell to battery packs to, they wanted to scale from 0 to 30,000 in a year. So they require the vendors also to support them with those kind of volumes, which are not present in the country even today. So keeping that in mind, we feel that as the numbers grow, the vendor network will also have to pull up their socks and come up with the volumes. And if that happens, then I feel the OEMs are more than willing to buy from outside, provided that we as vendors ensure the right quality, right product, and we deliver that at scale to them. So if that happens, we don't see this being a challenge.
Okay.
Having said that, some companies might want to control this being a critical feature. Tata Autocomp also sells to other companies. It is not just selling to Tata Group. So they also make for other companies, two-wheelers and four-wheelers and buses also.
Right.
So they have also put that company with an idea or a strategy that it will be a battery pack company that will grow on its own. So we don't see this. I think there's synergies here. And that is why we have come out with an implant model wherein we invest in the inventory of battery packs, we design them and we make it in-house for them so that they have visibility and control over the quality and the supply that goes to them on a weekly basis. So that is, I think it will evolve into that.
And also like I feel like the market is way too nascent right now to talk about.
Yeah, it's too small.
100
years ago, when Ford came out with the first vehicle in 1920s, 1930s, they were making the glasses, they were making the tires, everything was in-house. Eventually, everything was given out to the vendors and they focused on R&D and sales and distribution, which is the forte of any auto company today.
Correct.
So they are only controlling 4 functions: R&D, service, sales and marketing, branding. So this is where it's not like what the vendors are making today. The OEM does not have the capability to make it. Even for ICE vehicles, they have the capability to make everything. But the question remains that do you want to put investments in everything or you want to focus on your core competence, which is the vehicle.
Makes sense.
So we expect this to continue and we expect it to mature, and battery pack players will always have business on the mobility side.
So you have a presence abroad as well? Does Neuron Energy currently have that?
We used to export lead-acid golf cart batteries
to
Maldives, Kuwait, Saudi, Dubai. But beyond that, we have not explored international markets yet. Right now, we are running projects for three-wheelers, L5 and L3. And we are actively working on the drone segment. So keeping that in mind, our bandwidth is completely full for the next 6 months to explore the international markets. Also, we haven't done enough justice to the Indian market yet, considering the volume that is available that we can work here. So these are low-hanging fruits that we would, access them first rather than trying to penetrate into the international markets. Having said that, there is demand there. So we see Africa as a good opportunity for us in the future, where two-wheeler, three-wheelers and LCVs have started selling significantly. So we will be developing those markets in the near future.
Right, but not immediately.
Not immediately, within a year maybe.
Okay. So let's get a little technical and talk about battery manufacturing on the whole, not just your company, but the industry as it is. So what sort of batteries do you all make? You told me already LFP and NMC, but can we get into a little more detail as to what the differences are and what the pros and cons of running either are?
So when we designed Neuron Energy, it was designed from a customer first approach. So we had started actually with lead acid as the base, and then we built lithium-ion on it. So we realized that time lithium-ion was expensive. So we thought that price being an issue in the Indian market, there will always be 2 plays available. Whenever the cell prices increase, we will see the customer moving towards lead acid to average out. And whenever the price will soften, the load will be on lithium-ion. The preference of the customer is lithium-ion, provided that it comes at a certain price.
Right.
Now, having said that, this year we have reached a price parity when it comes to lithium-ion. The prices have dropped significantly. So most of the customers are preferring lithium-ion. We are working on 3 to 4 platforms when it comes to technology. Lead acid, we are just getting off it and getting done with it. Lithium-ion, we are working on 2 to 3 types of chemistries. One is LFP, one is LMFP, and one is NMC. These are the 3 chemistries we are working with. LFP is the cell made with lithium, ferro, and phosphorus as the metals in it. The advantages of LFP are that it is lesser energy density compared to NMC. So it is more voluminous. It comes in a size of 32-700, which is the 32 mm is the dia of the cell and 70 mm is the height, which are the fatter cells that we used to get from Everready and Duracell. And that's the normal size, not the thinner ones, the fatter ones.
The AA types.
AA types, yeah. So that is the size at which an LFP cell is being made in. And it will occupy 30% more area than NMC to give the same energy. So it is slightly more voluminous. Beyond that, it is safer. You will not see an LFP battery or batteries designed with LFP going into sparks and all. If you penetrate it or puncture it also, worst case there will be white smoke coming out of it, which can be segregated. So LFP again works better between plus 10 degrees and plus 60 degrees temperature. So it's well suited for the Indian climate. Versus NMC. NMC stands for nickel, manganese and cobalt. Now, when you go deeper in NMC, there are different ratios in which this chemistry can be mixed. One is 5:3:2, which is 5 parts of nickel to 3 parts of manganese to 2 parts of cobalt. And the other one is 8:1:1, where 8 parts of nickel to 1 part of manganese to 1 part of cobalt. So we use 5:3:2 more, considering there is more cobalt, it's more expensive. 8:1:1 is cheaper than 5:3:2. NMC as a chemistry, if you use good quality cells, A grade, better cells with good IR ratings and good voltage range, they will perform well. However, they will always have the risk of a fire or something happening. It can be random. Obviously, the cases will be way lower if you're using a very good quality LG, Samsung, Goshen kind of a cell. But you can never bet or say that we are fireproof when it comes to that chemistry. That chemistry is widely used also in our mobile phones and power banks. And that is the reason when you go to an airport or something, they say that you'll have to take your power bank, you can't check it in, considering it might have a thermal runaway incident.
Right.
So keeping that in mind, that chemistry has always worked that way globally. We see that these two chemistries predominantly running. 3-wheeler is completely LFP. 4-wheeler was NMC moving to LFP. Right now, majority of the players are LFP based, most of the packs. And in NMC, we see applications like 2-wheelers. We see applications like drone, which are NMC, or they have another cobalt oxide, LCO, lithium cobalt oxide, LCO, which is a chemistry predominantly used for drones.
Right.
So these are the two chemistries where we see certain niche applications being there. Now, a drone battery might require 10C, 25C discharge, because when it flies, it has to carry the weight of the drone. Also, it has to power itself to great heights, which requires significant amount of discharge current, higher than the capacity of the battery. So you need certain type of cells that will support it. Also, the battery has to be very light. Otherwise, the center of mass of drone moves and it might not be able to fly stably.
Correct.
So keeping the stability in mind, it has to be certain grammage that has to be given to the battery only.
Okay.
If it shifts by 2 to 3 grams also, the drone will have issues flying. So it's a very significant specific requirement that you have when it comes to drone batteries. And NMC would work well in certain 2-wheeler applications because of its, like a motorbike or a super bike might not be well designed with an LFP battery in the 2-wheeler.
So essentially because of how much more smaller the battery can get with the same power.
Same power, and how much more power is required because 2-wheelers are compact.
Right.
So there's not much space available. Right. You need to give space for storage of helmet, cabins, etc. below the seat. So keeping that in mind, the entire space is not available for the battery.
But then in things like these, your BMS and temperature controllers become very crucial, right? Because they have to be running overtime to make sure.
So BMS has to be very crucial. We use a microprocessor based BMS. In fact, we were the first ones in India to come out with a microprocessor based BMS. That time, majority of the battery pack players were selling batteries with hardware BMS.
Okay.
Which is a MOSFET based BMS with just voltage upper cutoff and current lower cutoff. That's about it. So voltage up and down, current up and down, but it never used to manage each and every cell.
Okay.
The issue was price. The BMS was around 800 to 1000 rupees. hardware based. Our BMS we were using microprocessor was around 2,800 to 4,000 rupees. So it added a 3,000 rupees delta on the pack itself, just adding the BMS. But with the BMS, we could completely control the battery pack. It is the CPU of the battery pack. Each and every cell could be controlled. So that was missing before, and that is why we saw a lot of fire incidents happening in 2021 and early part of 2022, where a lot of two-wheeler fires across India were reported. There were two reasons. One of use of inferior quality NMC cells, and because again they had to match the price, and second being the hardware BMS, which was unable to control this. So these were the two things that were pushing the inferior goods into the market.
Right.
When we came out, we were very conscious of the fact that we didn't want to sell something that is not correct, number one. And second is our conscience didn't allow us to go into a price play where someone's life is at a risk.
Yeah.
So we decided that we'll go with a smart BMS only. There was a huge pushback from the market in 2021-22 that this kind of BMS that you're putting in, we don't require it. So you're putting it just for your benefit rather than ours. But we decided that we will sell it even if it is at lower margins. So if you see our company financials, our gross margins were really low in 21-22. We were selling at 5%, 4%. However, in 2022 September, August, we gave a lecture in Columbia Business School of Battery Pack Design and all. That time, Niti Aayog director had attended that lecture. And then they picked up a lot of things from the battery pack design and they made it into the AIS 156 norms, Amendment 3 Phase 2 norms, where they have made the microprocessor based BMS compulsory for all the packs. So since then, the entire market shifted to the smart BMS being the norm.
Right.
And we had introduced a smart BMS with Bluetooth in it, where we could remotely repair a battery pack anywhere in India, Nepal, Sri Lanka, Bangladesh, via connecting via WhatsApp or something of that sort. So that allowed us to not invest heavily on service across India because volumes were lower. So we had service engineers in certain locations only, and certain locations we were remotely repairing the packs. Even today, out of 100 calls, 90 calls are repaired via remote assistance. Only 10 packs out of the 100 calls go back to the factory where a physical repair is required. Right. So these are the nuances that we had developed early on. Today also all two-wheelers and three-wheelers that we are selling are with only smart BMS. In fact, certain partnerships that we have developed in the BMS segment, very few companies in India have that access. So we have some vendors in BMS where they have worked on our firmware and build a customized BMS for our requirement. And globally, Toyota and multiple other countries are using a similar BMS in their vehicle.
Okay.
So for India, we have that monopoly and that access because we were using this kind of BMS since a while.
Right.
And that has benefited us in building our L5 portfolio and the four-wheeler portfolio because you'll require such kind of heavy BMSs for the usage in those segments.
Now, speaking of cells, you spoke about the quality of cells being very important. So how do you choose your cells, and subsequently, how do you choose the vendors to go with?
So we have a vendor program in place which vets each and every vendor. See, there are different types of cells. Each vendor might not be good at all types of cells.
Okay.
So like a brand which will be good in prismatic is not necessary that it might give really good cylindrical cells also. Prismatic are mainly used for three-wheelers, cylindrical mainly used for two-wheelers. So keeping that in mind, we have chosen different cell vendors for different applications rather than choosing the company and using it for all types of applications. So based on the capacity of the cell, we have chosen the vendor. And there are two strategies that we use in the Indian market. One is a very high premium cell where we use an Eve or an REPT or a Goshen for the requirements, which is predominantly in the L5, LCV or four-wheeler segment. In the L3 segment, which is the low-speed rickshaws, we are using a slightly cheaper cell, but equally good cell. But the cycle life is around 3,000 cycles. So in that category, they don't require the vehicle to run for 10 years, 15 years unlike a four-wheeler or an HCV or an L5. So we don't use cells with 5,000 or 6,000 cycles. We use cells with 3,000 cycles, which will run for 7-8 years, which suffices their requirement, and our warranty is around 3 years on those packs.
So when you say 7-8 years, how much of those 7-8 years will you be getting consistent performance that is similar to the initial stages of the battery?
So battery goes through degradation.
Right.
It's very natural. It's electrochemistry, so it's bound to degrade over years. If you see our cell phones also, the batteries don't behave the same way after 2 years, the way when a new phone comes in. The idle time and the usage reduces over time. The same is the case with batteries which are made with lead acid, for starters, used in our cars. The cars are also idle. You'll have to kickstart them, and the battery performances goes down. So that's the DNA of battery per se. So you can't change that, but we can put a number to it. So if we take the rickshaws for example, the new battery that we give them, which is a 5 kilowatt hour battery pack, they run around 100 to 110 kilometers in a day. They have a motor of around 1000 watt to 1200 watt, and it gives them 100 to 110 kilometers, which is more than required for the rickshaw driver for the day. Beyond that, it's physically also tiring to run the rickshaw over 110 kilometers in a day, because you're doing it within the city.
Right.
The range that we are talking about today, if it's a newer battery which is 110, our battery packs go through a degradation of around 3 to 4% year on year. So in 3 years, you expect the battery pack range diving down from 100. If it's 100, it will come down to 91, 92. If it's 110, it will come down to 98, 100. That is the gap when it comes to the battery pack or the degradation that will happen. Now, the life of the cell is measured at 27 degrees Celsius and at a discharge current. So it's a technical feature. So you have to understand the vehicle to understand the life of the battery pack. We can't really say that this is how it will work. So let's assume as a case study that we are talking about low speed rickshaws. Their running current is around 35 amperes and their peak current on slope or on load goes to 60 amperes. Our battery pack is 100 Ah. So when you divide 35 by 100, it's around 0.35 is what the discharge current is. So the cell life is calculated at 1C discharge. So if the discharge current is lower than 1C, in this case it's 0.35, then the cycle life won't get affected.
Okay.
So in this case, if it is 0.35, we expect the 3000 cycle life to stand.
Okay.
That it will deliver that cycle. One. Second is it is calculated at 27 degrees Celsius. Now our temperatures anywhere are between 40 to 45 degrees Celsius. So keeping that in mind, there will be slight degradation on the life of the battery. Maybe a 3000 cycle battery will work for 2500, 2600 cycles rather than 3000. So it depends on the maintenance then, but it will be lower than 3000, that we can safely assume. So in that case, this battery, if you take a rickshaw driver, he will run it for 300 days in a year because he runs it every day. In case of a two-wheeler, it will be very low. We don't run it daily. It will not cross 225 to 240 days. So our norm for two-wheeler personal use vehicle is that it doesn't cross 220 days in a year. Considering holidays, weekends, vacations, etc. You put all that in, festivals, 220 is max that someone would drive it daily, full range. So using that yardstick, if you are giving a 3000 cycle life, divide by 220 will be a 8-10 year life. Yeah. And 8-10 years is probably the life of the two-wheeler also. People are bound to change it before that. Similarly, for the rickshaw, it will be, if you take 300, it will be 6-7 years that the battery will work. But there will be continuous degradation. Yeah, after 3 years, it will be 90 kilometers. 3 years after that, it will be probably 70, 65 kilometers. Okay. So it depends. It won't be the life. It will probably at a certain range. The rickshaw driver might say, now I can't, I need more.
Yeah.
So I need to shift. And similarly, a two-wheeler guy might say that, okay, I need at least 80 a day. Now I'm getting only 60. So either he will change his battery or he will change his vehicle. So that is when the shift or the next purchase will come in.
Right. So you were saying 40% of the cost of the vehicle is the battery. But how much of that percentage is the cost of the cell in the battery?
Cell in the battery would be another 70%. So on the vehicle front, it will be around 25% is cell.
Okay. All right. And so you were telling me that the cost of lithium and all is coming down drastically.
Yes.
It's still not at a point where an ICE vehicle, an equivalent ICE motorcycle, and an equivalent EV motorcycle are the same price. Do we see that happening at all? Is that something that is
We
possible
are
in the future?
almost there at the same price now. The delta is very low.
Hmm.
So if we see the electric two-wheeler market right now, there are certain models that have come out at 50,000 rupees by certain players. 49,999, 75,000, 90,000. These are the prices. So if you see an Activa, it's selling at around 90,000.
Correct.
So we are almost there with the price parity. There is not much difference. Having said that, two-wheeler ICE guys, the vendor network, everyone enjoys a good margin. Today, our margins are slightly squeezed at 5 to 7% basis point. So we expect at volume this to correct itself. It's a volume issue now.
Okay.
So volumes are still lower. Once we talk about 2 lakh packs, 5 lakh packs a month, at that scale, the business unit economics would fall in place.
So you would be able to break even despite having the price similar to a nice.
We are PAT positive even today. Last year also we were PAT positive. The question is that when we scale, there are significant amount of investments that are happening. Now, when the chemistry is moving from LFP to NMC to LMFP to sodium ion to multiple others, what should you invest in? So that becomes a key component of your strategy, that what technology are you banking upon? All the machines that you use for NMC might not be used for LFP. Similarly, all the machines for LFP might not be used for sodium ion, so on and so forth.
So is there any data that suggests that, okay, this type of cell, this type of battery looks like it has a much longer future than, say, XYZ?
We are very strong about LFP.
Okay.
Prismatic cells that will remain as a big bet in India for the next 15-20 years.
Okay.
And we will see cell manufacturing investments also happening around this space only. Because cell manufacturing is a more riskier game. If LFP and NMC shift, the LFP manufacturers cannot overnight make NMC because it's a very standardized fixed product. So keeping that in mind, we are betting heavily on LFP prismatic as the chemistry for 3-wheelers, 4-wheelers and any other above applications. For 2-wheelers, it will remain cylindrical. You can't go for it.
So that will be NMC.
Prismatic. It might be NMC LFP mix. Okay. But it will be cylindrical as the form factor.
Correct.
And it will be prismatic form factor for 3-wheelers, 4-wheelers, etc.
Okay. By cylindrical, you mean each cell in the battery pack will be a cylindrical cell versus a
prismatic
is a laid out.
Prismatic is a flask shaped cell.
Okay.
It's a rectangular cell, which is like flask shape. So it, as a form factor, again, it's not feasible to put that into a 2-wheeler.
Right.
But it will stack up well with a 3-wheeler, 4-wheeler, LCV, bus truck.
When you have a wider surface area to put it across.
And it's a higher capacity cell.
Right.
So you might require 10 cylindrical cells instead of 1 prismatic cell. Depends on the capacity. So you can't have that many connections in the bus. For a 2-wheeler, it's more compact, so cylindrical is probably giving a better output there. Also there you have different form factors. You have 18700, 21700, 26650. So these are different types of cells. Ola has announced 4880 right now.
Correct, yeah.
So these are different form factors and sizes of cells which might be useful for that particular 2-wheeler.
Okay. Now I want to talk about the ethics of battery manufacturing because there is a bit of a grey zone there as well. So a lot of the raw materials that are required for making a battery pack, which include the cells as well, so they employ kids or the working conditions are not great. So how do you make sure your chain of supply doesn't come from a place of this? And so, more importantly, can you even identify which companies are doing this and which companies aren't, like from a supplier point of view?
So currently we have stable supplies of BMS and cells from China, Taiwan, Vietnam. So we have visited, these are top factories globally. These are not only factories in China, they have operations in Singapore, US, UK, multiple places. And we have not seen any of these kind of unethical activities happening in those companies. So they are pretty much free of it. Same with BMS. BMS is a very technically engineering product. So we have not seen, it's not very labor intensive per se. So we have not seen this kind of activities happening there either. Having said that, we have nickel strip manufacturers, metal box manufacturers. Now these are low value items that go into the pack. So it would be very difficult to vet each and every one of them. So till now we have not come across these activities with our vendors per se. But like having said that, we use multiple types of wires, multiple types of fuse, metal boxes, then we use aluminium boxes and so on and so forth. So it will be very challenging to completely control the vendor because there are many child parts. But for the top 10, 15 child parts that we require, we don't see ethics being an issue here.
Okay. Now, another topic when it comes to the conversation of batteries is recycling. Now, I think as from the consumer point of view, it's still very nascent for us to really understand the technicalities of that. And there are a lot of talks about recycling, second life cycles and all of that. But then again, those talks were there for plastic also, but we have a lot of landfills stacked with plastic, which nothing is happening. What is the case with batteries and what is realistically the recycling case?
So recycling is pretty much possible with batteries. See, when I don't think plastic is a correct comparison. First of all, any metal that exists is recyclable. So if you talk about lead acid batteries, today 99.99% batteries are made with non-virgin lead. So we don't see lead mining happening at all. There are batteries, our car batteries, we have a buyback offer from our distributors. So they fit a newer battery in the vehicle, they take back the old battery. Companies like Exide, Amaron or smelters, they collect all this scrap and there is a scrap market for it. The rate of scrap is somewhere around 90 rupees to 100 rupees a kilo right now. And lead price in India is somewhere around 170, 180 rupees a kilo, which is fresher lead. So this goes into the smelters or this goes into any smelting plant, be that of a battery company or an individual smelter. They take the lead, put it in the furnace, they break it down. They remove the sulfur and the sulfation that has happened over the years, and fresher lead is then mixed with antimony and different alloys based on the requirement and is sold out. And the same lead is again used by the battery manufacturer to make batteries. So these lead ingots are bought. The same is the case with steel. You will see scrap iron and all of this happening. The same is with aluminium where you recycle it. So metals per se have this capability of recycling it completely. Now when the cells are made with lithium, manganese, cobalt, they are nothing but metals. Ferro and phosphorus are lower value metals, lesser extraction capabilities compared to nickel, manganese and cobalt, which are high value metals. What happens is today when we are using a vehicle with petrol, diesel, we are importing oil, we use it in the vehicle, it becomes smoke. Again we import oil, we use it, it becomes smoke. Again we import oil, use it, becomes smoke. So there is no recycling coming in. Wherein even though we don't have cell manufacturing in India today and we import cells, but it is a one-time import. Once you import them, you use it for 3-4 years. Once they are done, you will put the cells for recycling. There are many companies which have set up recycling in India today. Examples are Loham, etc., which have developed recycling really well, where they will be taking these cells, recycling them, and they will have raw materials, lithium, manganese, nickel, cobalt, and many other smaller metals also. They'll be extracting them and they'll be selling these metals to cell manufacturers, which becomes a raw material to sell. Cell will make the cell, give it to packs. Packs will again sell in the market, collect the buyback, give it to the... So it becomes a complete ecosystem.
Right. So tell me one thing. Now, if you're using freshly mined nickel, cobalt, whatever, versus recycled nickel, is there a difference in the density of the energy that it can store? Is there any difference in all of that, or is it like for like?
With other metals, there has not been a case of any difference whatsoever. So we don't see a difference being there. When you say that we can completely recover the metal, means that it will have the same characteristics as the older metal. It really doesn't matter. It's just a process through which you are extracting the metal from it again.
Right. So when you're recycling a battery, 100% of it is recovered? Like 100% of the elements are recovered?
100% of the elements won't be recovered in the same quantity. It doesn't happen in lead either. It will be lower.
Is it significantly lower, or is it like a small delta?
No, it won't be significant. It will be small delta.
Okay.
Around max 5-10% loss would be there.
Okay.
But it depends on the chemistry. It depends on the type of cell. You can't have a general rule here that this is what it is. With lead you can, with aluminium you can, but they are very mature 100-year-old metals being used for applications. These are newer metals which have found newer applications. So once things mature in 5 years, 7 years, you will see this number improving over time.
Right. And is there something as that we as consumers can do to help with the recycling process, or do you think even at the manufacturers or the recycler side, are there processes that can improve the efficiency of recycling, or do you think we are already at the best that we can get?
No, we are not at the best. It's a continuously improving technology as we speak, but we don't see being a long tunnel either. We see this number of what we get from lead or aluminium or other metals, or the quantity we recycle from other metals, the similar kind of characteristics hitting in with lithium soon. Also, it is a numbers game. Today, if we see, lithium-ion batteries have not really come back. We have started.
Correct,
yes, we've started selling them 2-3 years ago. They have not lived their first life either. So the companies who have set up large processes don't really have access to huge raw materials.
Correct.
Come at their place today to recycle them and all. I mean, if they talk to two-wheeler companies, Ather, Ola, they will be more than happy to work with a recycler with all the batteries that will be coming back soon, as they will make some margin out of it also
Correct.
as the battery will come back.
Correct.
So there will be demand 100%, but today the volumes are very low.
Yeah.
If we are selling 10 packs, they live 5 years. We have not hit the 4th year, 5th year today in the life cycle of a battery.
And the whole recycling thing will also help companies hit their sustainability goals as well.
So the ecosystem will be built in the next 6 years. Right now, we are just building the technology. Once volume comes in, we will come to know what kind of extraction, what percentages can we extract, so on and so forth.
But are schemes and rather techniques being already worked on to be able to work as best as possible with recycling lithium?
Yes.
Okay, now let's talk about the Indian manufacturing scene. Has the government taken note of the fact that there are Indian manufacturers trying to make batteries, and are there any subsidies involved for y'all?
So government has 2 schemes. One is on the vehicle side, which is the FAME scheme,
correct,
where they are subsidizing the battery purchase. We had FAME 1, then FAME 2 came. After FAME 2, there was EMPS, which was a shorter scheme for some time, which will get done soon. Then they have announced the PME drive scheme, wherein 10,000 crores worth of subsidies is available between 2-wheelers, 3-wheelers, trucks, ambulances, so on and so forth. So that has also come in. So subsidies will be available. The way FAME 1, FAME 2 was distributed, PME drive has a different distribution mechanism. But in essence, it will remain the same, that around 10 to 21,000 rupees will be available as subsidy per vehicle to the consumer. This is on the vehicle side. So indirectly, the battery is getting subsidized through this program. But since you can't track the battery because it's a B2B sale, whereas a vehicle has to be registered in RTO, that's a better mechanism to track consumption of the FAME subsidy. Second is that for cell manufacturing, government has a PLI incentive scheme, wherein government is giving production linked incentives for certain type of cell manufacturing to be set up in the country. So those kind of supports are available. Beyond that, there have been significant efforts by Niti Aayog to have access to lithium, manganese, cobalt, multiple other metals which are going to be used in EVs. So we see government bidding for many mines globally over and above what is being done in India. So that efforts government is taking, that before cell manufacturing comes into India, we need to have security of supply of raw materials. So supply of raw materials for cell is just metals. So metal supply is critical, and that can happen only from 2 places. One is raw fresh metal being mined, and second is recycling. So government is pushing heavily on these 2 things so that the entire ecosystem is developed faster.
Right. So would this mean, like, as of right now, we've been seeing a lot of, like, even in your company, for example, a lot of battery manufacturing, battery assembling, but we don't see much in terms of cell assembling in India. So do you think this will help that expedite that process?
Yes, 100%. So today, China has built its cell technology because it used to supply mobile phone batteries to the biggest players globally.
Right.
And based on that mobile phone tech, they have increased that to other applications like EV and ESS, etc.
Right.
So because electronics was such a large play there that has allowed them to use that same platform and grow it in the mobility segment, reducing the dependence on oil. India didn't have that. India was not very active with electronics manufacturing, although now it's significantly picking up. You see semiconductors and all of these things being spoken about in India, and that we'll manufacture in India and sell in India. So since this manufacturing is coming into India, mobile phone manufacturing also has significantly come into India. So having said that, it makes complete sense to have cell manufacturing now in India. So there are large projects that are going on. There are many players who have taken significant steps to come up with cells in India. Exide, Ola, etc. have announced their cell manufacturing lines. Even Amara Raja has announced. So we will see cells coming out in a year or two.
Okay.
From these factories.
And now that lithium reserves were found in Ladakh, if I'm not mistaken, do you think that will have any effect on this whole process? And do you think that will also help in making cells cheaper?
So lithium reserves were found they have announced 2 to 3 sites where it's been significant. One is Rajasthan, one is Jammu, and one is one other location around Karnataka somewhere it's been found. But there has been no announcement in terms of the quality of the reserves or the quantity or what will be available.
Okay.
So it will be too early to comment that, because these reserves have been announced, it will be cheaper and all. Having said that, anything that is recycled is in India. One-time import of metal is in India. So obviously, if you use a metal that is based out of the local availability, it will have an impact. Secondly, the customs duty in this budget on metals have been reduced to 0.
Oh.
So keeping that in mind, the government has put that out also, that any metals that are coming into India for manufacturing of cells won't have customs duty. Okay. So that will also have an impact on pricing.
Okay. So, but the fact that it's been found in India may not have a significant impact on pricing.
It will be a delta. It won't be too much of a significant impact.
Okay.
But it will be delta.
And so, now since we are not talking about cell manufacturing yet, where do y'all do your innovation? What is the areas y'all are innovating in the battery technology in?
So right now we are focused on battery pack design. So we are focusing on 2-3 aspects of battery pack. One is improving the energy density without having any kind of thermal imbalance or of that sort. That helps us. Second is improving the thermal management. Third is practically innovating, or probably saying that taking some bets on random chemistries and trying to see how they work in the market. So what happens in the lab and what happens on the road is very different.
Correct.
So we have been making some packs and putting it on the road, putting it on road testing. The vibrations on the road are very different than labs. The load on the road on the vehicle is very different than labs. So if you two-wheeler is fine, four-wheeler is fine. But if you talk commercial applications like a bus, it's usually overloaded. A cargo vehicle is usually overloaded. So all that impact comes on the performance of the battery. So we have been we have been adventurous in trying to put that out. So we have 3 main focus areas for the next 12 months. One is that how can we improve energy density without really impacting the cell performance. Secondly, setting up a very large R&D lab where we'll be testing more than 15 to 20 types of cells for years, like 1 year, 2 year, 3 year, different temperature areas, etc. Micelio has set up such a lab in Bangalore. So currently we are working with them for those testing facilities. So this will help us bring out different designs, innovate in terms of cell use, etc. and put out in the market.
Correct.
So it's not that simple that, you just put the cell, assemble it and goes. So the design, efficiency of design is very critical when it comes to how you pack the cell and pack the pack.
Right. And in terms of infrastructure, what do you as Neuron Energy have as of right now? So apart from the OEMs on-site manufacturing that you'll have, what do you have as Neuron?
So we are using 2 contract manufacturers currently.
Okay.
One factory is in Pune, one is in Noida. Both put together, we have a capacity of around 550 megawatt hours, which will translate into a top line of somewhere around 600-700 crores of revenue. So that this kind of capacity is installed. We have good cell grading capacity. We grade all cells. BMS testing is in-house. Having said that, we have laser welding. auto spot welding for two-wheeler packs, and laser welding for three-wheeler and higher packs.
So these are to weld the battery
Packs together, bus bars with the cells,
Right.
etc. So this welding things have been put in place. Sorting is auto. We don't do any kind of manual sorting, but we are still a semi-automatic plant. Like you will see labor moving the pack today. As it evolves, we are planning to do a capex of around 50 to 60 crores to set up a large, completely automatic, robotic, mechanized plant. But the drawback of a robotic, mechanized plant is you need a standardized product, which it can develop at scale. So currently, the issue remains that each model has a different pack.
Correct.
So customization remains a challenge. So if we put robotic plant, then we will have to run a pseudo semi-automatic plant on the side to ensure that other kind of packs are put out in the market.
Right.
So maybe we can shift the standard pack which is selling the most to an automatic plant and everything else in a semi-automatic plant. But it will take some time to reach there. So we don't have standardization yet. We don't have swapping interoperability yet. Each OEM has its own pack design, own pack chemistry. So standardization becomes a big challenge. So keeping that in mind, we have to build our infra. So in terms of infrastructure today, we have around 1 lakh square feet of facility all put together, which is good enough for our requirement today. We do 100% cell grading, cell sorting. Pack design is very stringent and our quality is very stringent. Production head comes from Tata Group and he has built the entire line there. So keeping that in mind, we are very strong on production quality, although it's a contract manufacturer's plant.
Right.
But having said that, we plan to do a capex of 50 crores very soon, in a year or so, where we'll be setting up a large plant for at least 1 gigawatt hour capacity. Which
So
will
you
give
are
us
also looking at becoming a gigafactory essentially.
Yes, our revenues this year will be in the range of 150 to 200 crores. So in essence, this year we are expecting energy sold per se to be around 150 megawatt hours. So we need to scale at least 6x, 5x, which should be 2 years from now or on that base, where we cross 600 megawatt hours, 700 megawatt hours annually, where it will make sense to have this kind of capex put in.
Correct. That makes sense.
Otherwise, today there'll be empty capacity if we do the capex
Correct.
today.
Okay, so that seems like a shoot your brains enough. What other future plans that you have that we should be looking out for?
So apart from this is where we are right now for the next 2 to 3 years. We are just looking to scale this to a top line of around 600 to 700 CR in the next 2 to 3 years. Mainly coming out of mobility as the base. As the 4-wheeler, 3-wheeler, 2-wheeler guys scale, it will automatically give us revenues. And over and above that, we will be entering different segments, which will be into the energy storage space and also into the solar space, where we'll be making battery packs for the backup of the grids and solar inverters along with a battery pack, which will give 300 units of power free to each home. So this kind of investments will be made over the next 2 to 3 years. In fact, we have started developing products for the ESS, energy storage segments, solar, telecom, grid walls, etc. And we expect this to scale to another 800 to 1,000 crores in the next 5 years.
Okay.
And government is shifting majority of its applications into this segment. So we are seeing in Delhi that diesel generators are being banned. And diesel generators are being replaced by lithium-ion battery packs as a power backup for industrial use. So such kind of applications are increasing for batteries which never existed before. So we will see Neuron growing beyond mobility. But having said that, mobility is our core. So we will be focusing mainly on 2-wheeler, 3-wheeler, 4-wheeler for the next 1-2 years.
Okay. And are you locked into battery packs only, or as the mobility evolves and we get newer technologies like hydrogen fuel cells and all that, do you feel like you'll be willing to do that as well?
We, as the name suggests, that we are an energy company and we are selling energy today. Today we are selling energy in the form of battery. Tomorrow we might be selling in the form of hydrogen or others. So we are completely open to it. So the idea is that fossil fuels, petrol, diesel, kerosene are the old energy fossil fuels. CNG was the bridge fuel. and battery, lithium-ion, sodium, hydrogen will be the new energy. So we will play a role in anything that is new energy, be it green hydrogen, hydrogen fuel cells, so on and so forth. Second is that today we are making packs. We feel packs is the core to cell and recycling. Once we have the volume in packs, we might backward integrate into cells manufacturing also, and we might forward integrate into recycling also to completely control the entire ecosystem. But we feel at 150 200 crores it's too small to make these investments. Once we have a captive cell consumption of 500 crores 700 crores, that is when we can set up a cell manufacturing plant which will have 50-60% consumption coming from the pack business itself. So we are still 2-3 years away from it. So that is where this is where our plans are when it comes to packs and it comes to the other.
Awesome. Thank you so much for being on this podcast with us, Pratik.
Thank you for having me over.
Thank you so much for watching. If you've been listening to our podcast platforms, thank you so much for listening. If you have any comments, leave them in the comment section down below. Any questions, we will answer them. If we can't answer them, we'll ask Pratik and his team to get back to us, and your questions will be answered. As always, thank you for watching, and stay tuned for the next one.